So today's topic, we will be covering the compaction test and its applications. Uh, uh, this is experiment sixth. I have already told there are 13th experiment, and out of that, five have been already covered. And from the next day onwards, we will be covering two at a time. So today's topics to be covered today will be introduction, the purpose of the experiments, and there are basically two types of compaction test. That is a light compaction test and heavy compaction test, observations and calculation, and what are its applications part. Basically the practicals which we conduct, basically this is the most important part is, this is practically we can apply in the field, and we can understand what are the concept behind the practicals we are conducting. So it's in childhood we used to learn the concepts, and we are unable to understand what are its applications, but at now in this stage you can directly see what are the application part. So basically the compaction, it is the process by which soil particles are packed more closely together by dynamic loading such as rolling, tamping or vibrations. So in the last class also I have covered the some of the parts of the settlements and dry density. So basically how the compaction occurs. If there are loose voids, if there are voids are available in the soil particles, so you can say we can compact it and press it such that the void, either it's air voids or the water voids, they get compacted and they get extracted out. Okay. So when they are getting out from that soil samples, automatically we can understand the compaction is taking place. Okay, this is very simple concept. So it is achieved through the reduction of air voids with little or no change in water content of the soil. The degree of compaction of a soil is measured in terms of its dry density. The degree of compaction mainly depends upon its moisture content during compaction, compaction energy, and the type of soil. For a given compaction energy, every soil attains the maximum dry density at a particular water content, which is known as optimum moisture content. So what happens here? You can see the at particular water content, we can see what is the maximum uh, dry density. Okay, at particular water content, if the water content is same, that means we have to remove the air voids. Okay, if there is no change in water content, what will be happen? Only the air voids will be reduced, and if the air voids are reduced, automatically we are going to get better density, dry density, and you can see the dry density value will increase. So basically, that is the concept, and you can see the compaction. Basically, what will be the result? You can see it. This is done in the roadways pavement. You can see there are rollings are going on. You might have seen in the roadways. Also, you might have seen during the constructions of the buildings, when whenever the foundations are going to come, we used to roll it, or through different means also, by tamping also, by hand means also. If you have excavated some parts of the field, obviously some loose soil particles are there. So removing that soil particles and tamping it properly, so we can make it compact. So basically you can see, if you have covered this, most probably you have covered it in the lecture classes, but you can see this is very important concept for all competitive exam point of view also. The maximum dry density and optimum moisture content, this is these two the points, and based on this concept there are various numericals are framed. You might have seen I have given the numerical questions, they are all from the gate exams. So very basic questions, but they are very important for all the practical viva, or you can say university exams, and even for the competitive exam as well. So this is very important concept. So what is the purpose? The purpose of a laboratory compaction test is to establish a relationship between dry density and moisture content for a soil under controlled conditions. R. Proctor in 1933 was the first to develop a method of assessing compacted field that has since become a universal standard, and the test is known as standard Proctor test. Proctor test is also known as light compaction test as per BIS, Bureau of Indian Standards, and also developed a modified test to give a higher standard of compaction and is known as modified compactor Proctor test. The same is also known as heavy compaction test as per BIS. So you can see here the same Proctor test, light has been standard Proctor has been a light compaction test, and the modified has been termed as heavy compaction. Okay, in terms of our Indian standards, you can say. So the principal reason for compacting soil is to reduce subsequent settlement under working loads. Compaction increases the shear strength of the soil. Compaction reduces the void ratio, making it more difficult for water to flow through soil. This is important if the soil is being used to retain water, such as would be required for an earth dam. Compaction can prevent the build of large water pressures that cause soil to liquefy during earthquake. So you can see by compacting the soil, most of the engineering properties are getting improved, and subsequently you can see if we can compact the soil properly, the foundations which we will be using, we need not to go for the big mat or raft foundations, or you can see the pile foundation or that. If the soil is proper compactions is done, we will be the settlement will be less, and you can see that settlement is very dangerous for our construction work. If there will be settlements in the buildings or in the foundations, you can see there are chances of the buildings to be to collapse. Okay, and also the shear strength will be increases. So you can see here the basically the descriptions of the molds and the rammers. You can learn this all the important points, so that it will be useful for you the competitive exams and practical vivas. Definitely the questions will be there from the light compaction and heavy or standard or modified. So we must remember these. So basically you can see the way the volume of the mold which we use for the test is the, you can see in the Indian standards it's 1000 cc. The same volume is there, but the difference will be, you can see the weight of the rammer. What the rammers we will be adopting and applying for the compaction purposes. The weight of the rammer is 2.6 kg in the standard light compaction, and is 4.9 kg in the heavy compaction test. So this is the difference. And height of free fall, the height through which we fall the rammers is 310 millimeter and 450 millimeter. And the number of layers which we are putting in the molds is in 3 layers, and also in the light compact heavy compaction it's 5. So in recently one of the exams I was giving the NSIT professor exam. So the same question was there. So these are all although it looks very simple, but the questions comes from these basic concepts. What the number of blows per layer? Per layer we have to provide 25 layers. So basically the difference is the number of layers which we provide, and the weight of the rammers and the height of the fall. Okay. So the formula for calculating the dry density of the soil, it's very easy. In the last class also we have discussed the gamma dry density is equal to G gamma W upon 1 plus E. You can see from the formula itself, if the value of this E will be reduced. Okay. So automatically you can see if the denominator the value of the denominator is decreasing, automatically you can see this value is increasing. Okay. And subsequently all the engineering properties are increasing, the bearing strength, the shear strength. Okay. So this is the basically the funda is that the if the we can reduce the voids, the properties of the soils are increasing, index properties as well as the engineering properties, you can see. So the apparatus, I have already told the specifications. Again, the apparatus which we are using, the cylindrical metal mold. Okay, you can see the mold. This is the mold. You can see the rammers. This is the rammers. The mold is fitted with detachable base plate and collar. This is the this is basically the size of the mold. This is the mold. Okay, and this is the collar attached so that we can compact it properly. There should not be the wastage will be there. The soil particles are compacted properly and the soil does not go outside. So there's a will be collar will be placed for the extensions of the mold, but it will be finally it will be removed. Okay, the mainly the mold is this much. So the balance will be there definitely to wet graduated jar will be there to pour the waters for getting the getting the moisture content. For what moisture content? There will be the maximum dry density of the soil. Okay, so basically we have to find out the dry density and the mm, optimum moisture content. For which moisture content, for what we mix the water so that there will be maximum the dry density will occur. Okay, so we will be adding the water subsequently straight as will be there for removing the soils particles which are on the top of the making like it's a curve. You have to make it at a straight edge. You can use the scale, uh, steel scale can be used. Spatula will be there, oven for calculating the moisture content of the soil particle and the moisture beans. They are basically the apparatus we will be using for this test. You can see in this is the collar mold extensions. This is the base plate. Similarly, you have seen that in the last test, same is the same, almost same base plate is there. The rammer will be used for the compaction purposes. For handling, this is the and this is will be the we will be releasing it. Okay, by we will be releasing that part and this hammer or the will be used for the compaction of the soil. So this is the weight of 2.6 kg and 4.9 kg. The procedures what we will be adopting here. The empty mold is attached to the base plate and it is weighted. Okay, the collar is then attached to the mold at the top. The wet and mature and moist soil is placed in the mold and compacted by giving 25 blows of primer uniformly is distributed over the surface. Okay, so the simple you can understand what we have to do. We have to get the weight of the mold first, include and then attached to the base plate and it's wetted. The collar is then attached and then the soil is placed in the mold and we started. And if it is the light compaction, we will be providing in 3 layers. Okay, and each layer will be providing the 25 blows of primer uniformly distributed, and the soil is compacted in 3 layers. Obviously, if it is a light compaction test, and the volume of the soil taken in each layer is such that its compacted height is about one third of the total height of the mold. Okay, so one third height will be taking. Before placing the second layer, the top of the first compacted layer is scratched for proper bonding of the both the layers. So the scratched, this basically it is for the forming a proper joint is there, cleaning it and proper scratching will be there. Because you might have heard in the or you might have studied in the RCC also when during the concrete pouring and if we are adding in some other joint is providing we or you can see the construction of the columns. You might have seen during the construction of the columns we provide joints. If we generally 2.44 meters height is there of the shuttering boards, so we provide that casting is done at 2.44 meter, and then we provide the joints at that place, and then again after some days when it is hardened, we provide again when the pouring is done of the concreting, we properly clean that surface. Okay, properly clean that surfaces. If there is any debris or anything, we remove it, and then only we pour the second. So similar is the concept is there. We have to scratch it properly so that there will be bonding is will be there. Okay, so you can see here through the figure how it will be done. Soil layer 1, 2, and 3 will be there. Okay, this is the cylindrical mold. Okay, simple. You can see the diameter is there 100 millimeter, and this is the rammer. We are dropping it uniformly at a particular time. You can see here the standard test drop distance is 310 millimeter and 450 millimeter. The hammer weight which is will be using for the light compaction will be 2.6 kg. If you could have came to the college, it would be very great. The geotechnical lab practicals you could have conducted in the practical, but nonetheless, you can understand the concept very simple. The second and third layers are also compacted by giving 25 blows of the rammer. The collar is then removed and excess soil is trimmed to level with the top of the mold. What I have told you earlier that the collar is that will not giving the volumes. Okay, collar is just for placing that. You can see here this has been fixed. This is the collar. Okay, you can see this layer. This is the collar. This is provided, and this is the cylinder. After the proper compactions, we remove that collar and the extra soils are there till the volumes till the cylindrical volumes. We remove that through the sharp edges. The mold along with the compacted soil is then weighted to get the mass of the compacted soil. A representative sample is taken from the center of the compacted soil for the moisture content test. Okay, so we have compacted it by proper hammering that 25 blows at 3 intervals, and then we finally get the mass of the complete soil mass. Okay, so after deducting from that empty mass, we will be getting the mass of the soil, and that sample is taken for the moisture content test. Okay, so the bulk density and dry density for the test is calculated from the known values of the mass of soil volume, mole, and moisture content of the each test. So similarly, we will be testing it again and again, and starting with the 4% of the moistures or 2% of the moisture or 4%. We gradually increase the moisture contents and see the weight. We take the weights. Bulk density of soil, you all know the mass of the soil upon the volume of the soil. Gamma D is equal to gamma B upon 1 plus water content. The soil is then removed from the mold and then mixed with original samples, where 2% more water is added in the sample and the test is repeated. So, what we will be doing, we will be adding the moisture content gradually and checking the weight. Okay. So, what we will be taking, we will be taking the different samples for different moisture contents, and we will be checking what are the densities, dry density of that samples. So, and automatically we will be drawing the graphs, and we'll be getting the which will be the best suitable graphs and for that master content, and we will be getting the values. The procedures continued until the mass of compacted soil begin to decrease. A graph is plotted between percentage water content and dry density. The curve obtained is called compaction curve, as on in the you can see here the standard proctor test. This is very important concept, and this is the figure. So in this y-axis we have drawn the dry density, and in the x-axis this is water content. Okay. So for every moisture content we are checking the here it is 6%. Gradually we are increasing the value 6 to 8, 10, 12, 14, 16% of the water content, and for each value we have got the values. For say for example for 6 we have got the dry density this much, and for 8 this much, and we draw this, and we getting the points for all the values and then joining all the points. Okay, so by joining it with the freehand we get this value. This is the maximum value you can see here. Okay, so the maximum value you can see at water content, that is percentage is 9 for 9 point percentage. This is an example. You can see 9 percentage. We will be getting the maximum dry density, and here we will be joining it, and we will be getting the, we have got this is 1.87 dry density gram per cc. What is the density of the water? You all know that is 1 gram per cc. Okay. So it is clear from the graph that dry density of soil goes on increasing as the water content is increased till maximum density is reached. The water content corresponding to the maximum dry density is called the optimum moisture content. So this is very important concept. You must remember it and you must apply it practically also, so that you can solve the numericals as well. So you can see from the graphs the values slowly it was increasing, and once it reached the maximum value, and if you will be adding more of the water will be increased. Obviously it will come towards the density of the water, because the mixture is getting more of the water are added. So the weight, or you can see the dry density will reduced further. Okay, so this is the basically concept. This is the practicals we have to conduct in the labs, and by doing this practicals we basically draw the figure. Okay, this graphs, and from these graphs only we get the maximum moisture content and optimum moisture content and the maximum dry density. This is the funda only. Take the empty cylindrical vessels, container, empty container, and then we take the weights, taking the weights, and then pouring the soil samples in 3 layers till that it covered the complete cylinder. And for each layer we will be providing 25 blows through the hammers having weight 2.6 kg for light compaction and 4.9 kg for the heavy compaction. Okay, and then from a particular height, and then we'll be removing that collar and shaping it properly and taking the weight, final weight, and then through that we will be calculating the dry density of the samples, and for the same soil sample we will be taking the moisture content through the oven. Okay, so both the values or dry density and water content we will be getting, and we will be taking around 6 to 8 samples, and through that we will be drawing the figures, or you can see the graph. uh, each points will be there, and we will be adding it, joining it through the freehand, and we will be getting the maximum dry density and the optimum moisture content. Okay, so you can see heavy compaction. Already told you the equipment required for heavy compaction test is the same as required for the light compaction, but Remmer weight will be increased and the height of refall will be increased. Soil is compacted in 5 layers. Okay. If the volume is, you can see some of the, you will be seeing that the blows are 55 numbers and we are getting confused. So you can see if the volume of cylinder we have used is 1000 cc, then there will be 25 number of blows will be there. Okay, and some where we have used 2250 cc mold volume, then there will be 55 number of blows, and the soil will be compacted in 5 layers only in both the cases. So these are the differences. If you will be asked what are the differences between light compaction and heavy compaction, so you can also, these are the 3 4 points you can directly mention. So basically what I've told, we have to take the empty weight of the mold with the soil, obviously volume of the mold. We have already get the water content in the soil will be there through the oven test, and then we will be getting the bulk density. Okay, and the dry density. Simple funda is there. Okay. So the resultant discussions, empty weight of the mold is equal to W1, and weight of the mold with the soil W2, volume of the mold will be V, water content in the soil, W, gamma B, whatever I told the same. You can see here, the when the water content is increasing, bulk density is increased, okay, and the dry density is also increased. But gradually, if we can see in the bottom part, okay, we will be adding water content will be increased further and further more. Slowly, you can see it will be started to decrease also. Okay. So equation for calculation of dry density. These are the formulas you have already covered. So I will be not going in detail for that. The same formula I have also in the uh, told you in the last class also. So you can see these are the formula. We will be air content will be 0. You can see dry density will be this much. Thus, for a same soil, the effect of heavier compaction is to increase the maximum dry density and to decrease the optimum water content. What are the application part? The compaction of soil increases its dry density, shear strength, and bearing capacity. The compaction of soil decreases its void ratio, permeability, and settlement. So you can see it will be reducing the void ratio and the permeability. Very dangerous for the dam constructions or the construction fields, settlements. The results of this test are useful in studying the stability of earthen structures like earthen dams, embankments, roads, and airfields. You can see the earthen dams, which are basically formed from the earth materials, and this will be very useful in these structures. So the compactions will be there, or layer wise layer. The compaction will be there. That then only we can be taking the heavy loads of the water forces coming in the earthen dams. In such constructions, the soils are compacted. The moisture content at which the soils are to be compacted in the field is estimated by the value of optimum moisture content determined by the Proctor compaction test. So you can see what are the energy imparted in the light and heavy compactions. You can see here the in the energy imparted in heavy compaction test. Obviously, we can see the potential energy mgh. We all know. So what is the energy? The mass into gravity into height. Okay. So 4.9 is the height. Sorry, 4.9 is the weight. 4.9 kg, and g is the 9.81 and 0.45. Okay, 0.45 is the height, dropping for 450 mm. If we will be converting into meter, that will be divided by 1000. Simple funda is there. And how many times? 25 blows and in 5 layers. Okay, simple. The concept you can, I have told you the concept that 4.9 kg. Okay, 4.9 kg is the weight, mass. Then gravity, you all know 9.81 meter per second square. And then the height from which we are dropping it, it is 450 mm. We have been converted into meters by dividing by 1000. And how many times we are providing the energy imparting in 5 layers. Okay, in 5 layers, and it is 25 blows for each time. Okay, obviously we have neglected some of the points. You can see, you will say, sir, if one layer is already covered, so the height will be decreased. But there is some of the these are has been considered. And similarly, energy imparted in light compaction, you can see 2.6 kg weight, G is same, the distance is 310 mm, and this is the in 3 layers. Okay, so 25 blows. So you can see in high compacted test how much we are imparting the energy, 2703. Okay, and in the light compaction we are providing 593. So you can see ratio is 4.56. This is also very important questions for Viva purposes, practical purposes, and exam point of view, and the also for the competitive point of view. One by one, we will be getting the concept and remembering each and every part, we will be very much confident for cracking any of the competitive exams. Okay, so the ratio of the energy imparted will be 4.56. Obviously the energy in the heavy compaction test is more. Okay, by how much? By 4.56 times. Okay. Oh, this is zero air word line. It means the soil is fully saturated. With the air is not present in the pores of the soil mass, it is obtained from the compaction test. The graph is plotted for dry density versus water content. To draw the zero air word line, the density, dry density is to be calculated, and that is expressed. Look, dry density already we have covered. Gs gamma W open 1 plus Gs gamma W. Here the term Gs is specific gravity of soil, gamma W is the specific weight, and W is the water content. The geo line drawn with the results obtained from the comparison is shown. So you can see here, this is the zero airward line, this is the graph, and this is the zero air word. Okay. So the table below contains typical values for the different soil types obtained from the. So you can also remember this value, or these are the given in the numerical CVP we have provided. So these are the soils. You also must remember this, how to take the names. Okay, the S and W. S for sand and W for well graded. S for sand, C for clay. Okay, S for sand and P for poorly graded. C for clay, low plastic clay. Okay, non-plastic silt and high plastic clay. So you can see these are the values. You can remember, or it's not very. So you can say the values are optimum moisture content are increasing for different soils. This is the value for different soils. So we cannot compare it together. Note that these are the typical values. Because of the variability of soil, it is not appropriate to use typical values in design test are always required. So obviously these are the typical values. We cannot use it directly. But yes, if these are the values are given, we can use it. So thank you very much. So basically what we have covered today is is that we have why it is important for the compaction purposes, why we do compactions for the roadways and the soils, and how we conduct the test. Okay,